Okay, let us update our list. So we previously executed the debug command H. So let me highlight this now. Also, we have used several times Q. So highlight na din po natin ito. So let's proceed. So we are going to demonstrate now the command N and W. So these two works hand in hand because on N, you have to identify the file name, of course, considering that there are contents on the file and that we have to write the file on a specific directory. So in this example, I will be using the default directory, the root directory C drive, where we have to write our file, the file name on N, putting this on our root directory. So let us now proceed. To do that, we have to enable debug. Then let's first execute simple code, like let's display a single character. So we have to assemble first, and that by default we have this offset address. Say we have the code move AH2, and this time we will be displaying a character, so I'll be using the data segment DL, and let's identify a character to be displayed. So we have the values here. So say let me select 72 is to display the character R. So we have to indicate the equivalent ASCII code. So letter R again is letter R number 72. So 72 po yung ilalagay natin dito so that we can display R. So we have 72, press enter. So we will be calling the interrupt 21 to execute this, and that to terminate we have interrupt 20. Press enter. Okay, so in writing the file, we have to consider the file name, as well as we have to estimate. We have the option to estimate the number of bytes. So in this case, we have 108 minus 100, so there are 8 bytes all in all, and that we can use as we declare this on our CX register. So R CX, so the default value of CX is 000 or 0, and that we have to indicate an allocation here. So we have 8 bytes, and if we are to update now the current content of your CX, press R and then enter. So CX now was changed to our identified value, and then we will be writing this file. So N, and think about of your file name. Say for example this file name is tst1.com. okay, tst1.com. Press enter. Okay, so a file name was identified, and that we will finalize this by writing this on our default directory. So that is by typing W, press enter. So writing 8 bytes because this was our identified number of bytes. Let's check on the file that we created a while ago. Press Q to quit and then enter. Let's check if our TST file was created. So to check the contents of our root directory, we type dir and press enter. So we have our file tst1.com, and this is 8 bytes as we identify the allocation. Okay, so since tst1 is existing, let's try to check if our expected output is there. So we have tst1.com. Press enter. Okay, so we have letter R because we have indicated the ASCII code for R, and now it's successfully displaying. You can also check the contents of the file in our emulator. So all you need to do is to open that file and click on the specified folder. So in the same way that we have saved this on our root directory, it also shows that in this Windows Explorer we have also tst1.com. So you have to click open for you to check on the codes that you have created on the file. So with this, we have the codes created a while ago with our file name tst.com. Okay, so since we already demonstrated this code, so let us highlight N. Okay, and we have also executed W. Okay. Nakayan ko lang ng konti. Kinakita pala. Okay, so let's proceed to the trace command. T for trace. Well, hopefully this time it's visible. So we have the T command. So let me start this with the code debug. Press enter. What is the T or trace command is all about? So the command steps through the program by executing the instructions one at a time, and thus this command allows the programmer with the ability to execute the instruction isa-isa. So this operation is known as single stepping program. May I repeat, this is single stepping program. So you have to trace this one at a time. And the single step operation displays the contents of the registers or specified memory locations before and after the execution of its instruction. So let's now test on the code. So we type first, bago tayo mag-trace, kailangan meron siyang basihan. So the basis of this will be our operation. So let us assemble first. And then let's do some modification on the registers, like we have move, this time we'll use CX, move CX2. So we are defining the value for CX. Then we have to give the value for the register DX. So let's do the same, 2 pa rin po. And then next instruction, we have to add the value. So we have this is our destination, we have our source. Okay, so hope you still recall on the mnemonics. And next we have to check on the register. So these are the codes that we executed a while ago, and then let's check on the contents of the register. So currently we have the value of the CX. This is the default value of the DX. So let's try to trace what happened. As we said, when we execute the trace command, it steps through the program by executing instructions. So it's a single stepping program. So let's have the first trace, T. So let's check. The first code is CX. CX, we're putting the value of CX is 2. So this is the result. And on the next code, move DX2. So T, let's trace what happened to DX. So we have the value for DX. And finally, we have the code add DX to CX. Add DX, CX. CX is our source, DX is our destination. So let's trace T, and this time we have the value of DX, which is 4. Okay, let's quit and start anew. Okay, since the trace command is demonstrated, let us now highlight this and let's proceed. A similar command to the trace is P, or proceed. So we have to identify the address and then the number. We have to invoke P and then the number. If a number is not specified, then it is a single step execution. Unless the number is specified, then the number of repetitions is considered. So what is the trace command is all about again. So again, siya ay single step, pero ang difference with P is that we can manage to iterate the number of steps as long as we are specifying on the arc list. So subukan po natin. Let me enlarge our display. So we have our DOS box, and to start the code we have debug, press enter. So our execution is now P. say we're just typing P. So by default, we have single iteration. If P is considered with a number, then the iteration would be equal to 5. So traces on this proceeds on up to the 5th iteration. So for us to check on the number of repetitions, we have 1, iteration 1, 2, then 3, 4, 5. So yun po yung kanyang response with code P5. So take note that these are also the results of the previous code on trace, only that this time our P is iterated 5 times. With T, we traced the code 1 at a time.